Part F, we were at the equivalence point. So we're going to continue this titration beyond the equivalence point. Notice it will do a quick upward spike and then kind of level off, but gradually rise. And what's happening when you've passed up the equivalence point? Well, you've consumed all of the weak acid, and now you are dealing with a strong base that has nothing to neutralize it. So the pH is going to climb higher and higher with that strong base. But you start the problem exactly the same way. We will construct an ICF table for the one-way reaction. We know the acid hasn't changed for any one of these problems, 4, 9, 8, okay? And what we need to know is how much base we have. And we are at 20.05 milliliters of that base. So the moles of OH, which are the same as the moles of sodium hydroxide, would be the molarity, okay? And it is correct on this slide, okay? Molarity of the base times the volume, 0.02005 liters. We're just beyond the 20 milliliters equivalence point. This is going to give me a value of 0.00499, okay? 0.00499. None of this, don't care about that. Now look at these two numbers and I see that this one is smaller than this one. I have consumed all of the smaller one, and that's how much of the bigger one I'm allowed to react, no more. I am producing 0.00498 of that guy. So I've used up all of this, and I have 0.00001 of this, and 0.00498 of this. So I've got myself a bit of a strong acid and quite a bit more of this weak base. But this weak base, if you remember back to its value of Ka, it's 10 to the minus 10. That's like more than 1,000,000 times weaker. I don't care if I have quite a bit more. It's 1,000,000 times weaker. When you do a problem and you get to this F line and you have a strong base and a weak base left over, you base the entire problem on the strong base. So this is the hydroxide, not molarity, but moles. I can't get the pOH until I know the concentration of hydroxide in here, and right now I know the moles. Okay? How do I get concentration? It's moles divided by liters, which we had 20 milliliters of the acid and 20 milliliters, 0.05, okay? So these are in liters now. We can add those values together. That is going to give me, well, let's see. I have no idea, because guess what? I, in my notes, forgot to do this step, okay? You do this step, and you can get an answer, and I'll pop it up on the screen. But let's talk about what it should be, okay? If this were just it, that would be a pOH of 5. Once you get and you divide these two numbers, it's going to be a little bit higher concentration than the number of moles, because you're dividing by a very small number, and that will give you the OH minus concentration. Once you have the OH minus concentration, then you can get the pOH from that. How do we do that? We take the negative log of that number, right? And then you'll take 14 minus that pOH, and you will have your pH. So, not clean and neat, because I, in my notes, forgot to do this step, but you get the idea. Once you've done this step, you can get the pH. The big key here is when you have leftover strong base, base the problem solely on that number. So we see in our graph at letter G there that we've done a bit of a climb, but we haven't done a massive climb. On the next problem, which is point H, I will have correctly put these values in and finished it off in style.